Hello to Highload DevCon from Munich, and today I would like to talk a bit about Java EE performance measuring and what you can expect from average or from stock application servers. So application servers without any modification. And let's start with a short introduction. So I'm just freelancer working with Java since 1995. I'm writing a blog from time to time, like a notepad. A few times a year, I'm organize workshops, and this airhacks.news is a mailing list which announces various events, like for instance this one. And airhacks.io is a bunch of online courses. So, and if there are any questions left, you can ask me questions whenever you like. It is at Airhacks TV, for instance. This is the first Monday of the month at 6 p.m. You can ask whatever you like. It should be Java and Java EE related. So, and this is a couple of workshop meeting airport, and now start with the content. So this was the last slide. We have no time, just about half hour, 40 minutes. So let's start with the content. So what I have here is an IDE with a stock application server. This is actually the reference implementation called Payara. And reference implementation. This Glassfish and Payara is like hardened reference implementation with lots of bug fixes. And I just started the Payara. And what I would like to do is to open the admin console. And the admin console here is interesting to see what's actually going on. So what I usually do in my projects, I set up the monitoring to high of all components so I can see exactly what performance we have, what exceptions happened, successful, not successful transactions. And such kind of monitoring, actually all application servers are able to provide for years. So you will see, the HTTP status codes problems, you will see transactions problems, you will see slowest method of EJBs. So I will show you in detail how to fetch the information in a second. What's also interesting here, we have the HTTP service, and as you can see, we have two listeners. The one is 8080 and the other one is 8181. This is SSL and this is the usual one, and they are referring to a thread pool. So we have one HTTP thread pool, and so what it means somewhere here, there is a thread pool called HTTP thread pool, and you see how it's configured: min thread pool size 5. Max thread pool size 5. So what it means, we have at most 5 threads, and if they cannot handle the load, it will be queue up to 4,000 tasks, and then we will get 503 exception, service not available. So if you are really into high performance and high load, you will probably have to change this default settings. Otherwise, your application server won't scale for slower transactions. On that note, you can ask me questions in the chat. So there's a Ustream chat, or use Twitter, just admb.airhacks handle. So admb.airhacks, use or the best would be if you would use just the built-in chat. Okay, so the server started, and we looked briefly at the threads. There's also a slightly more complex setting, and this is called Concurrent Resources. So what you can do, you can set up thread pools and pre-configure the thread pools and inject them and use in your app. So what it basically is, a built-in bulkhead pattern, similar to Hystrix from Netflix, but is built into Java EE. It doesn't provide as nice dashboards, but what you can easily do, just define a common set of threads for a communication channel, like for an I/O channel with the backend. Okay, these were the basics, and now I would like to develop a small application and see how it behaves. So I will call the application, first I need a project, and I will call the project HD for Highload DevCon. So let's create that. So what it basically is, a simple Java 7 app. And the simplest possible Java E7 app just comprises a single class. So go here and let's say load resource. We don't know whether it is high load or not. So HD, let's do it right way, boundary load resource. So, and now I can say I would like expose you as a resource. So I will call it load. And now a basic thing, I could say, okay, string, message, and it should be for me and for you, good morning. And a little bit dynamic output here. So this is the simplest possible Java 7 application, and I will build that and then run it immediately on this server here. So say run and choose the server and say go for it. So it's deployed. What was it? Resources, and I think it was load. So we have here good morning load. So the first thing which we can do, sometimes it doesn't work. So let's try this. This does work. So let's try this. Apache benchmark, 5 users and just 1,000 requests, and now do 10,000 requests because it was a little bit too quick. So Apache benchmark is a tool which comes with Apache. You can just use it right away. And what we see here that our connect time is 2 milliseconds, processing was 1 millisecond, and total 3 milliseconds. And we achieved, where was it? 4,000 transactions per second. So it's not very impressive, but the question is, what happens if we put here 15 threads? And now you see there was a little, waiting pause, and the problem was possibly the queue filled up with the requests. So I would just, we achieved 4,000 requests per second. It's probably something happened with the queue, so we should look at this. So far, any questions? No questions. So interesting. So 4,000 transactions per second, and now what we could do, we can go here to the Chrome and say, okay, application server, show me your data. And we have here applications, HD, and we see nothing here. So let's improve the situation. So we could go dig into this. So we would say at least, number of sessions, but nothing application specific. So I would just go here. There's JSON stuff, but nothing application specific. So I would like to improve the situation. So I would just go back. Nothing. So what I could do, I can say, okay, let's do it. Let's make it an EJB. So now it's an EJB. As you can see, something appeared. So what means EJBs are monitored resources, and the monitored resources appear in the application servers because all application servers on Earth has to monitor EJBs. So what we get a create count, method ready count, and remove count. So interesting information. So let's repeat the test. Probably just go with 1,000. So as you can see, we got 4,300 transactions per second. So the impossible is true. The performance, I think, improved a little bit. So now we have 6,000 transactions per second with an EJB, 4,000 transactions per second without an EJB. So this is quite impressive. So what we could look now, we have 2,200 EJBs were created. Current 5 method ready count. So what it means, there are only 5 EJBs active. So what is the reason for this? The reason for this is we have 5 HTTP requests and actually also 5 HTTP requests. Also, we started 15 threads. So what it means, it could be a bottleneck. So what we could do, for instance, we could go to the application server, to the console. Let's do this. And say here, where is our pool, HTTP thread pool, and max thread pool 15. Save that. Repeat the test. And go back here. Retry that, and you see current 15. So what it means, the bottleneck was the pool of the application server. Now our application, was parallelized a little bit more. We had 15 parallel requests, and if you look at the performance, we get 6,200 transactions per second. So we could Just increase it to 25. So now it queues up again. So the performance dropped because of the queue. And if we look here, nothing changed because the HTTP thread pool is still set up to 15. So seems to be an interesting information. And again, this information is available as JSON, which is really easy to consume. So what we build with that is monitoring in systems where where the whole night there were stress tests, and in the morning we would like to see the metrics. And this is actually a great way to do this. If you're interested in this, look at Lightfish. And Lightfish is a monitoring tool which goes more into into this GitHub project. So go to GitHub. And it will connect with Payara or Lightfish and produce some nice charts. So, so far, what we did, a little bit optimization. And of course, you shouldn't play with the max queue size too much because if it is too deep, the queue, what you can get out of memory errors. So, okay, so we discussed the basic performance. Still, it's not very impressive. So the next question would be actually what we can do here, or what actually happens if we create another class. And the class, we call the class load manager. This is the business logic. This is another EJB. And this EJB returns the actual payload. And this is enterprise good. Oh, beans are with you. Okay, so plus system can millis again, and I would like to inject this class here. Load manager. LM is perfect, and I will use the class here. So deployed. I would repeat the test with 15 again. So we have 4,000 transactions per second. It still queues. So we have 4,000 transactions per second. Now we get some errors because it is overloaded. And what it basically means, this injection has some impact on performance. But with EJBs here, each EJB is created once and pulled, and here. And this injection happens once per instance, not every time, if this were request scoped. So I just looked. Any questions? Everyone agreed? Okay, cool. Cool audience. What's about persistence? So persistence is a wider topic. If you would add persistence to the for instance Derby, we can create JPA. So what will immediately happen? You will see performance degradation because of I/O. Why because of I/O? Well, I/O is the slowest possible thing. So what I try to do here to give you an impression what application server can offer you performance. And if you get a database, you will be as fast as a database. So usually in real world, what happens? Application server are not utilized and the databases are overloaded. So so it really depends on the database, and it really depends whether you are accessing the database in memory. There are in-memory databases or over the socket, and over the socket you will see performance degradation, of course. Okay, thank you, Anthony, for the question, and yeah, and this. So we have 10,000 transactions per second now because the queue is empty. So you see, the performance really depends on the settings of the application server. So what happens in real world? So what I did, there's one project, I interviewed one of my clients, and they are using Java EE for manufacturing and IoT systems, and they have in production for years. So actually we started with Java EE 5, 25,000 remote procedure calls per second, and 1,500 clients are connected, and the latency is 50 to 100 milliseconds. But they are doing a lot, and what's also involved, a database is also involved in the communication. So if you're interested, I would just paste this in the chat. look at this. And this is a really serious application, 24/7 and highly available mission critical system. So I would just put it in the chat so you can pick it up. So now, how to look into the application server. So we got a basic impression. So just we go back here and let's go to the console. To this one, where was it? For 4848. So what you also have, transaction service, and you see a number of commits. So we started in our test 52,000 transactions. No active transactions is going on. So let's start the test again. So I will let's do just 10 threads and increase it a bit. Still no active, but 62,000 transactions per second. I'm too slow. So why is this important? Because you are actually seeing whether we are testing something or not. And again, JSON view is also available. Committed count, and what's very important is rollback count. So what could happen? We have crazy good performance caused by rollbacks. And let's go here. What you also get, we can monitor the connection queue overflows. So what means here? We have 0 overflow so far, which is interesting. And HTTP listener 1. So we can monitor here connection. So the health is still okay. And the thread pool from the HTTP listener is here. And you can see core threads is 5 and max threads is 15. So it actually, the setting was taken from the admin console. Okay, so now for application developers, what we do, we start with JVisual VM. I thought it's gone. This will be terrible. So there is a JVisual VM, and I would like to connect to Glassfish. And what I see here is the memory consumption. So there are no tales going on about the memory consumption of application servers. Now what we can do, we can perform garbage collection, and you can see it goes down to 84 megabyte of RAM. This is a stock full, not micro, nothing. This is full application server. And why so important is to estimate, how much memory the application server actually consumes. And so not this. So we don't need this. We need this. As you can see, this is the spike, and we have a short spike. So there is some correlation between the threads and memory consumption. But you can see we have here 150 and 100. So there's like 50 meg difference. And it just disappeared immediately. So it's really very important to watch how the application server behaves under load. And there's another tool what I use frequently, and this tool is called JMeter. And with JMeter, it cannot generate as much load as the Apache benchmark because, or it consumes more resources. But I can basically say I would like to have five users and create a sampler, and the sampler is HTTP request sampler. And what we would like to do is to have a local host with 8080, and I think the path was HD resources load. Is it true? HD resources load, and the only thing we need is like a summary report just to see whether we get errors or not. So I will launch that. No summary, and we see we have 2000 transactions per second. This is actually not that interesting. What we see, there are 0 errors. So now, why I'm starting this first, now we can see what is the true impact of performance. You see, to memory, it consumes a little bit more memory. So it goes back to 90, but it recovers immediately. So what would be interesting, we have just allocated 500 megabyte of RAM to Glassfish, so there is no pressure to the garbage collector to actually be efficient with the garbage. Okay, so what we also see here, number of threads. This is interesting. So we can sort the threads by name, and what we should see is the I think these are the threads here. Where are the HTTP threads? This is, here are. These are the HTTP threads. These are the 10 threads. As you can see, there's nothing to do for them right now with JMeter. Why not? Because I only started 5 of these threads. But here you can see, how overloaded is actually the front end of the application server. What's also interesting, we can start CPU profiling. And why the CPU profiling is interesting. So what we can look at this at the actual overhead of EJBs or Java E. So I would go to com.airhacks and look at our EJBs. So we see here there's a boundary EJB. This is EJB 3.1. We have a payload CDI bean and load resource message. And what you can see is the performance overhead is negligible, so it doesn't even appear here in the first page. And what is the main overhead? This is NIO network, of course, is the communication between the network, the load balancer and the application server. So I will stop the test for a second, because otherwise my machine gets hot. And meanwhile, I will look at the chat. So this is where is the chat? Any questions in the chat? No, lazy chat. I got a private message, or don't write me private messages during the session, so you can write official ones. And let's see, HDConf probably are here some. Oh, I see myself. This is nice. But no questions. And you have to write in English. I have no idea about Russian language. Okay. So we are pretty far. With that, now about what we can do within the application for high load applications. So the problem we have the HTTP threads. In one point of time, they could be overloaded with work. So it would be a good idea to pass as soon as possible the work from the front end threads to our own threads and maintain a thread pool per communications channel. So how to do this? So thankfully we have Java 8. So it is really nice. So we can say get payload, a method. So I will try to do it a little bit nicer. Or no, you are a highly skilled audience, so forget about the nice things. Just go to straight Java 8. So suspended async response is the name. Async response. And what happens now? Now the HTTP thread is suspended, so actually pass back, and the control is passed to our thread pool. We still don't have one, but we get soon one. And now I can say, okay, the response has one interesting method, and the method is resume. So, and with the resume, we can pass the payload here. So this is an asynchronous call. And so we could just, where's my JMeter? We could repeat that with JMeter. So go for this. No. So it started. So now look at the performance here. So this will be a lot of difference. So, what would be interesting here are the threads. What's the behavior here? And as you can see, so the threads, there is actually, they have almost nothing to do because the control is passed to another thread. So we just stop the load test again. It's like, okay. So, but this is not enough. We would like to have more control about this. How to do this? Well, where's my IDE? Oh, that's, I think, a question. Oh, Alexandra Lomov asked me, could you please tell me more about practical aspects of using AB and JMeter? So practical, I think what you mean practical is real world. So for if we had a little bit more time, I would show you JMH. Is a Java micro benchmark harness. This is what I use in real world to get reliable numbers. This is just to give you an impression of the performance of application server. So I always use AB Apache benchmark for like no smoke test to find out what the application server is doing, and JMeter for sustainable load like this. So I just generating load and monitor the performance. And if you go to wait a second, admin GitHub and Java EE testing, you will find. Oh, wait a second. So you will find examples for my online course about testing. And what I did towards the end of the course, I created, this is Java EE testing. I created, this is the online course, but I created a benchmark with stress test and JMH. And what's interesting, I use JMH for this. And there is a test like CDI versus EGB. Is it here? CDI EGB stress, and this is based on JMH. This is JMH benchmark. So look at this if you're interested. So in one project, client asked me to prove that the application can sustain several thousand transactions per second in a cluster, and so we created a executable jar, and we could performance the stress test whenever we wanted. And this is practical. This is what we did in the real world. So, and this JMH gathers the performance data. So what's also interesting, I measured here the performance CDI versus EJB, and it turned out that EJBs are a little bit faster, 20% faster. And then at GitHub, if you search for GitHub CDI versus EJB, you will find someone who is called Samo Lisov, and this is, I think, a Russian IBM expert. And what he did, he just took my example and created some metrics, and what he measured, the performance impact, the performance difference between Spring, EJB, and CDI, and unsurprisingly, EJB won because of the pooling, what I demonstrate to you right now. So if you would like to repeat the test at home, just clone his repository and just try that. Okay, so practical means in production, I use more JMH to have reliable numbers. You can specify in JMH, what is JMH? It's like Maven plugin, so you can launch, and then it generates a jar which is executable with all dependencies, and you can specify it whether you are interested in throughput or whatever, and you're working with annotations and configure the thing with annotations. So I hope I answered your question. And JMeter, in JMeter, what you use for stress tests, what you can do with JMeter, you can launch JMeter, I think, with -C flag and point to configuration in a headless mode. So if you launch JMeter here, JMeter -help, is there something like this? You will find the settings. So, and there are some -n is no window, and there is property file. There's a test. -t is a test file. So what you can do, you can launch JMeter in headless mode. What we do on Jenkins. Okay, I hope I answer your question. But now, this is at least what I would like to show you is this. So now let's. We are somehow high performant, but not very robust. So now change this. So what I did right now the thread is executed immediately, which is not a good idea. So therefore, there is a nice utility called completable future. And this completable future, we can supply a task which supplies something. And in our case, this is the EJB. You say, nice, this EJB, the method payload supplies a string. And then this response consumes the string, and now we build a pipeline, and a nice one. So what we also get for free, we can say, okay, hence we are high performance, the timeout should be 1 second. And after this, the client gets the default HTTP status 503 service not available. What you can also do, you can say set timeout handler and specify a timeout handler and specify your own response code in case the server gets overloaded. So it's kind of handshake with additional header information. Now this is still a little bit problematic because this supply async uses async pool, and the pool is based on fork join pool. So let's improve the situation, and I will inject managed executor service. And this managed executor service is a executor service from JDK 1.5 or 1.678, but managed by the application server. And what we can do here, I can pass the managed executor service here. So, and now we created a pipeline which is executed by managed executor service. And remember that our application server here, where was it? Where is our admin console? Not here. Here. We have here asynchronous resources somewhere here. And we injected basically this managed executor service. There's only one. This is the default one. And we injected this one, and it has quite a high number of threads. So you should also play with this. It's a little bit too optimistic. So what we could do right now, so we just go back to the to JMeter, where is it, and launch it again. This was not very wise because we lost our configuration. But what you will see here, you see already we have some executor service threads, and just very quickly create it again. And you have now full control how concurrent this channel becomes, and for every resource on endpoint you can create such a pool, and this is called bulkheads pattern. So I would just skip that. So if I would relaunch this, you will see that the HTTP thread has nothing to do anymore, and the full control is in your executor service. So I would just add, just very quickly, threads forever and 5, and this was a sampler, I think, exactly, and this was HTTP, and we said we are local host 8080, and there was HD resources load, I think, and then we only need the summary listener summary table, and now launch it, no saving, and go for it. So it looks nice. So, and what's the difference? So where are the threads? These are the HTTP listener threads, and somewhere should be the pool with, this is this pool thread, this is the threads here, and they are busier. So what happened is we pass control from the HTTP thread to our thread. It does not change anything at the performance, but our system becomes more robust because we can just slice the total number of threads and dedicate threads for a communication channel. So I get a question here. Adam, what about scaling beyond a single machine? Go to my YouTube channel. I actually did it, and what I did it, you can very easily with Docker. There's not a Docker course, but would be very easily to start a Docker. And what will happen? We use usually HA proxy, which load balances to application servers, but surprisingly, it also the performance is less because the HA proxy consumes some via the redirection there's some performance penalty, but of course you can scale better. So with Docker, it's not a problem. If you're interested in it, I will stop this. Wait a second. So go to my YouTube channel, and I think Adam being YouTube, exactly. And one of the talks is going to be load balancing. Load balancing Java microservices. So look at this. I think this is 9 minutes video. So from scratch, I'm building a service and load balancing the service. Okay. Any other questions? So hdconf. If I add some logging, the performance will disappear basically. So system out println will be the most terrible stuff, and file logging is slower, and network logging depends, of course, on your infrastructure. Meanwhile, it's almost faster than persistent logging. Okay, but what I actually wanted to show you, so how the time is almost over. So the very last thing, what I actually did, created a very small library called Porcupine, and if you are interested in high performance Java, it is already used in some projects. And what Porcupine does, I will use this Pi version. So we just add it. So go to GitHub and search for Porcupine, and then what I can do, I can say add inject add dedicated. Dedicated means this is a qualifier, and now I can just go with the straight executor service, and I will call that HD pipe. HD pipe, nice name. And yeah, just rebuild everything. And what it allows you to specify on the fly thread pools without reconfigure the application server. So what it basically means, I can go here and say exactly, and now -E. So what you see, I injected statistics, Porcupine statistic HD pipe, pipeline name HD pipe with rejected execution handler. So what you can do, a rejected execution handler basically means you can specify the behavior on overload. This is standard. It comes from the standard comes from JDK 1.5. So look at the rejected executor handler, and you can specify different executors handlers. And it comes with defaults like you see here: completed task 1, core pool size 8, current thread pool size is 2, largest thread pool size was 2. And now we could perform our little stress tests. So A, B, minus C, 5 threads, minus N, let's say, I don't know, 5,000. So, and now look at this, and you see completed task is 5,003. Largest thread pool size was 8. So and maximum pool size is 16. So the pool was not overloaded. So what you can also do, you can of course inject several such pools, and each injection will create behind the scenes a new pool with this name, and they will be isolated. And this is, I would say, a true bulkhead pattern. What's interesting, because we have Java E, the whole dependency is just, this is the Porcupine spy. They are just a view classes. So this is actually one class which cares about the dependency injection. And here the other, so it is empty. What's in dependencies? Where is it? Here, no. So I don't get it, it's even empty, shouldn't be empty. But the other one is like 3 classes. So wait a second, just go, this is the truth, this is the war. There's a class lib, this is the Porcupine 0.4, and there are a view annotations, a view classes, and this is lambda, so you see more than one. So so this is actually used in production, and you can configure as well the executor service using the name HD pipe. So I think there is a question. There's a logging, and go to hdconf tag. Okay, no questions in the chat. We are almost over time. So what the only thing what I would mention, we used REST so far. Application service comes with WebSockets as well, and if you have to send a lots of messages, WebSockets come with far better performance because the header is tiny, and the HTTP header consumes some, so I would say HTTP header are kilobytes and WebSockets is a byte. So there's a huge amount of traffic going on in smaller messages. So just see whether I will able to configure it on the fly. And hex HD boundary custom HD pipe configuration extends executor configuration. Executor configurator, not configuration. Sorry for that. So, and what I have to do, I will have to override a method. And this method configures a pipeline. So the pipeline name, we say if a HD pipe equals name. So now we know we are here. Then we can do the following. You could say, okay, executor configuration dot default configuration dot, and now I can say, whatever, or I can build one and say this. Sorry. New executor configuration dot builder, and now say dot, for instance, which behavior on overload, abort policy, call-around policy. Call-around policy means basically back pressure, so the thread pool will block. I can register my own custom rejected execution handler, discard oldest policy, and the interesting part, abort policy, call-around policy, custom rejected handler, discard policy, and so forth, they already come with JDK. So this is not, custom Java invention. Keep a lifetime, max pool size. So what we could do, we can say, let's say, call-around policy, queue capacity is 10, and then say here, core pool size is 5, max pool size is 10, build, and we return this here. Return. So, and I have to say specializes. So it means take this one. And so I think the glassfish died. And I will have to rebuild this. So what it basically means, I can have one configurator or more configurators and actually specify the behavior if I cannot live with the standard. So is it deployed? Run. So, and now if we go here, we see rejected execution handler, call-around policy, and we see here maximum pool size is 10, active count is 1. So what we could do, we could say queue capacity maximum pool size is, let's say, 3. This will be hard, is 2. 3, queue capacity is 2. So there is current pool size is 1, core pool size. So, and now we can say AB, and repeat the test. And go back, and we will see largest thread pool size was 5. So now the thread pool was overloaded. There are no rejected tasks so far. So we would have to increase the test. You see, remaining queue capacity was 10. So just go with 15. Just go with 15 and repeat. Go here. Still no rejected. Remaining queue capacity is 10. So it's really hard to overload an application server. So I wanted to give you actually a brief. Still. So we are out of time. So thank you for watching, and see you on upcoming conferences, probably even in next AirHacks TV. This is exactly the same venue we use right now. So if you have any questions left, go to AirHacks TV. So this is first Monday of the month. And what you can also do, ask questions in GitHub. So in GitHub there is, you can prepare a question and ask in advance. There's already a couple of questions for the next AirHacks TV show. And see you on upcoming conferences, workshops, or come to Munich. So the next workshops, microservices, and testing are in December. So thank you for watching, and bye.